Hello class, welcome to Unit 2, Day 4, tangent and secant lines. In a circle, a tangent line is a line that hits the circle at just one point. So like if you look at the circle that's there, AB would be a tangent line. So it doesn't go inside the circle, and that point right here is called the point of tangency. If you draw a line going through a circle that hits 2 points, that's called a secant. And we don't call these points of secant C or anything crazy like that. This is just a line that hits the circle in 2 points. So the tangent has some special properties, which we're going to see right over here. If you draw a tangent and you draw a radius coming up to that point of tangency, it's going to make a right angle. So in this problem, AB is tangent to circle O at P, then we say AB is perpendicular to OP. Perpendicular, you could also use that symbol if you want. So how do we use that? We solve some problems. So you know a lot of things about right triangles, hopefully at this point. So in this problem, example 1, again, we got a tangent line. We were told that this is tangent to circle O. So since we have a diameter here, then half of that's going to be a radius, and that radius will make a right angle with that tangent line. And so our goal is to figure out what angle X is. Well, if I know that's a right angle, that's 90 degrees. And inside of a triangle, you'll notice that all three angles on a triangle add 180 degrees. So if you ignore the circle for a minute, just think about, all right, I got a triangle with two sides. I got 90 and 38. How do I get X? Add these up, subtract from 180. So these are going to add to 128. And then when you subtract that 128, you should get, let's see. You want to take a minute to put that in your calculator if you're not sure. X is going to be it's going to be 52. Double check that for me. That should be the measure of that angle. So the measure of angle E is going to be 52 degrees. All right, moving on to example 2. All right, we got another right triangle inside of a circle. Instead of focusing on the angles this time, we're going to focus on the sides. So once again, we got this tangent line here, AB, which means since I have a radius, you got a right angle. But this time I want to find X. I want to find the side, not the angle. So how do the three sides in a triangle relate to each other if it's a right triangle? We can use the Pythagorean theorem. Which states that the sum of the legs squared, we don't have to use A and B, it's just the two legs squared and added together equals the hypotenuse squared. So A squared plus B squared equals C squared. And so this 10 actually is the hypotenuse. I know sometimes people want to say that's the hypotenuse because it's coming out of the circle, but the longest side of the right triangle is always going to be opposite the right angle. So we're going to use X and 8 for the legs. It doesn't matter which way you do them, but the 10 has to be on its own side of the equal sign. So we're going to square those and subtract. X squared plus 64 is going to give you 100. And when you subtract that 64 away, you should get 36. And so to solve for X, we're going to take the square root, and X is going to equal 6. Well, X is the radius, so in this case the radius of the circle would be equal to 6 units long. Okay, example 3. Again, we got another right triangle. We got a side here, and we got a partial side. Go ahead and put a right angle in there since it says it's tangent. And what we have here, we got this 8. It's not the whole hypotenuse, but it's this chunk of it right here. And our goal is to find the radius. So I'm going to put an R there. Now, you might not be aware of this, but in this circle here, 8. Yeah, so we have the radius here, and in this circle, this segment's actually also a radius too. In fact, you can draw a segment anywhere from the center to this edge of the circle, and it's going to be a radius. So what happens is that hypotenuse is actually composed of 2 parts. It's got the radius and that 8. So I'm going to go ahead and call that R plus 8. So when I'm setting up a Pythagorean theorem, it's still going to be a squared, b squared, and c squared. C is the R plus 8 here. But what we have to do is we have to square this binomial out. And so what I'm going to do is I'm going to write r squared. 12 squared is 100. Yes, r squared plus 144. When we square a binomial, it's going to be, well, you can think about writing it twice if it helps. R squared, r plus 8 times r plus 8. And what's going to happen is you're going to multiply the r times r, which is r squared. And then you're going to do the r times 8, which is 8r. Then you have another one of those. You got to do the 8 times the r, so 8r again. And then you got to do 8 times 8. So you got all this on the right side. In the meantime, my left side didn't really change. So what I want to do is I want to get this solved for r. And so I'm going to keep my left side, just bring it down. This is going to be r squared plus 16r plus 64. And so now we got to look at seeing what I can do to simplify this. And you'll notice, well, hopefully you see something that's on both sides that can be subtracted out. These r squareds. Sorry about that division line. It's not really division. If you subtract those, they cancel on both sides of the equation. So we got a nice, easier equation to work with. We don't have to worry about squares at this point. 144 equals 16r plus 64. And if you take that 64 away, 144 minus 64, what is that, guys? You put that in your calculator. And that's going to give you 80, I believe. And our last step is to divide that by 16. So canceling those 16s out, your radius is going to be 80 divided by 16, which is, I'm going to try it on your calculator, 5. Just in the meantime, just make sure, if anything you want to do, if I'm working too fast, pause the video and see if you can do it on your own. And so that value of the radius is going to be 5. 5, 5, r equals 5. This is going to make 13 here altogether. And if you plug 5, 12, and 13, you're gonna fit the right Pythagorean theorem quite well. All right, here we have 2 tangents. We have a tangent going to this point at A, and we have a tangent going to this point at C. And those are going to be congruent to each other. Anytime that you have, think about it. If you're wearing a hat, as long as the sides are the same, hopefully those 2 segments are the same. So we're just going to mark those congruent. And this is as simple as just setting them equal to each other. If I have the 2 segments here, we want to find the value of x. So we're going to solve this equation. So we're going to take that 5x away from both sides. That's going to be 2x minus 3 equals 1. Next step, solve for x, is to add 3 to both sides. Let me move that over here. So 2x is going to be 4. And that's going to give me, when I divide by 2, x is going to be 2. So when you see something like those, the segments are going to be equal, set them equal to each other. Continuing that pattern here, what we have is we have another figure, and it's got two tangents, BA and BC. Those are going to be congruent. This is kind of drawn a little bit not to scale here, but you gotta put a right angle in here anyway, because these are both radii, KC and KA, so they are going to form right triangles. And so I want to go through and label the sides here. So I have KR as 15, and I have BC. Where's BC? BC is 68. That's the tangent line, and we want to know what is the length of KB. So in this problem, a couple things come to mind. The first thing is, if I just focus on what KB is in terms of this right triangle, whether you look at the one on top or bottom, you should notice that it's the hypotenuse. So we are going to use a squared plus b squared equals c squared, KB being the c. So the problem is you got to have this side, and it doesn't matter, KR, KA, KC, all three of these segments are a radius. They're all radii. So I can put that 15 anywhere I want. I can put it there. I can put it there. It's going to be most useful right here, because then I have the 15 and 68 as legs of the triangle, and KB is what I'm trying to solve for. So what I'm going to do is I'm going to do 68 squared plus 15 squared equals, we'll call it KB. I can use that as the name of the side. That way I don't have to call it C or hypotenuse. And when I want to solve that, I'm going to have to square those and add them and take the square root. And I cannot do those in my head, so I'm going to plug these into the calculator right quick. 68 squared plus 15 squared is 4849. All right, so solving for KB, I want to take the square root. And let's see what we get. So the square root of 4849 we're looking at about 69.63. All right, that's all I have for the front side. The next video will actually be the back side of the notes. So if you need to go back, please feel free to rewind or pause and go back and look over your notes so you can do your day 4 assignment. Thank you.